All right, this is section 5.3, exponential functions and models. So what is an exponential function? First, well, it is a function of the form f of x equals c times a to the x. A is greater than 0, not equal to 1, and c is greater than 0. Some examples: f of x equals 2 to the x, g of x equals 1/2 times 0.2 to the x power, and f of x equals 3,000 times 1.02 to the x power. And notice, by the way, on f of x, you can see that c equals 3,000 and a is 1.02. On g of x, c is 1/2 and a is 0.2. And on the first one, f of x equals 2 to the x, c is 1 and a is 2. Notice we don't have to write the 1. It's 1 times 2 to the x, but you don't want to write the 1. You also don't want to multiply these. That's not proper. You can't do it. It's against the what is true. That means 1/2 times 0.2 to the x power is not the same thing as multiplying 1/2 times 0.2 and then to the x power. You remember the order of operations, right? It says you have to do the exponent first and then the multiplication. So you cannot do the multiplication and then the exponent. All right, let's get a little closer to the action here. All right, so we have some examples of what these functions look like. On the left over here, this is where for all of these, c is equal to 1, and we have a, and you'll notice for the first one, a equals 2, a equals 1.5, a equals 1.3, a equals 1.1, and as you get closer to a equal to 1, the curves is flattening out more and more and more as a gets closer to 1, and if a got bigger, like 3 to the x would be steeper. If you look at the other one, this is a values less than 1 but greater than 0. And you notice the first one down here is 0.9 to the x, y equals 0.7 to the x, y equals 0.5 to the x, y equals 0.3 to the x. And as they get farther away from 1, they actually get steeper also. Notice the number actually gets smaller. 0.5 is bigger than 0.3, but 0.3 is steeper, all right? The one that has the a equal to 0.3. All right. Let's look at some characteristics that are listed here. So first, the domain is from negative infinity to infinity. That means there's points all the way across from negative infinity to infinity. And the range is from 0 to infinity. That means the graph is above the x-axis. Okay? Does not touch 0, right? It is continuous. The x-axis, which is y equals 0, because all the points are above, it never quite gets to 0, is a horizontal asymptote. You guys remember that word? Horizontal asymptote. That means the graph will get forever closer and closer, but it'll never touch the x-axis. The x-intercepts, there are none, right? Because it doesn't touch the x-axis. The y-intercept is c. In this case, notice it's 1 for all of those, and c was equal to 1. Because f of 0 is c times a to the 0, remember that's your x right there, and a to the 0 is 1, so it's c times 1, which equals c. All right. If a is greater than 1, then f is increasing on its domain. That's those, when a is greater than 1. And if a is less than 1, greater than 0, it has to be greater than 0. But when it's less than 1, then it's decreasing on its domain. That means it's falling as you go to the right. As you span to the right, or as you scan to the right, it's falling. All right. The function is 1 to 1. Remember 1 to 1, where you could draw horizontal lines, and if they cross at only one place on the graph, then it's 1 to 1. And 1 to 1 was important because that means we have inverses, and we will see those. Not today, but later. All right. Let's take a look at an example here. It says, find a linear or exponential function that models the data. So how do we know which one it is? Well, remember the linear are of the form f of x equals ax plus b, or mx plus b. And the exponential, which are the new ones that we're looking at, are f of x equals ca to the x. What's the difference? The linear has a slope, right? So that means if we can identify a slope, it's the linear, and if we cannot, then it's the other one. Okay, so let's take a look at the slope here. So you'll remember that we looked at the slope, the jumps in y over the jumps in x. So the jumps in y on the first table, it goes plus 1 and then plus 1. I'm just counting the jump, right? Plus 1. And notice I write plus 1 because it's going up by 1. And the jump in y, that's minus 3. minus 3, minus 3, minus 3. So that remains consistent. The slope, remember the change in y is, it's change in y over change in x. So the slope is negative 3 over 1, which is negative 3. Okay, so that means we should be able to find, this is a linear, and we should be able to find an equation of this form. Now, to find, by the way, the equation, we need to find m and b. We found m. What is b? Well, b is the y-intercept. Remember, for the y-intercept, x equals 0. So it's given to us right there. So the y-intercept is 1. Yeah? All right, so our function then is f of x equals negative 3x plus 1. All right, how about the other one? Well, we try to do the same thing. So we check to see if it has a slope just like the other one. So this will be plus 1, plus 1, plus 1, plus 1. But when we try to do that down here, this is plus 2, and then it's plus 6, so it doesn't work, right? It's not linear. Okay, what does work? Well, if we look to get from 1 to 3, if we multiply by 3, that works, times 3. And if we try the next one, 3 times 3 is 9. And 9 times 3 is 27, and 27 times 3 is 81. And that is, in fact, the way you recognize exponential, that you have the same factor being multiplied sequentially to get to the next value of x. Okay? So we've identified our a. That's our a. That 3 that we're multiplying by is our a. Notice it's what we multiply by to get to the next one, to the right. All right. What's our c? Well, c is the y-intercept, which means where x equals 0. So here, f of 0 is equal to 1, which then is equal to c. Yeah, c is f of 1. So we have what we need to construct our exponential function. Our exponential function is f of x equals 1 times 3 to the x power. I'll write it that way. Actually, I'll write it this way instead. 1 times 3 to the x power. And then whenever it's a 1, we don't need to write it. So we can write this as f of x equals 3 to the x power. And I can leave it like that without any parentheses. Okay? So there's my answer for that one. Okay? All right. Let's try the second page. And same type of question. This one says, find values for c and a so that f of x equals ca to the x. Satisfies the conditions. All right, so I'm going to start off letter B. I'm going to leave letter A for you guys. I'm going to start off letter B. So letter B says f of 1 equals 2. And first I write it this way. So f of 1 is c times a to the 1 power, right? Equals 2. And f of 2 means c times a to the 2nd power, right? That's x, the exponent. And that's x equals 8. All right, now I can write a fraction with these. I can say ca squared, which is that one, over ca to the 1st, which is this one, equals the numbers that they equal. 8 over 2, which is 4, right? All right, so this reduces to a 4. On the left-hand side, the c's cancel out, right? And the a squared over a to the 1st is just a, so I get a equals 4. Okay, so how do I find c then? Well, I just write one of these. F of 1 equals 2, or f of 2 equals 8, whichever one. I'm going to go with, it doesn't matter, so we'll use this one, f of 2 equals 8. So f of 2 equals 8, so f of 2 means c times a squared equals 8. That's what that means, right? That's f of 2. C we don't know, but a we do know. So this is 4 squared equals 8, right? A was 4. And then we just solve. So this is 16c equals 8, I'm sorry. And if we divide by 16, we get c equals 1/2. So there we go. We have f of x equals 1/2 times 4 to the x power. And that's our answer. All right. Let's try letter C here. An investment currently worth $180,000 is losing 3% of its value each year. How much is it worth after 6 years? All right, so we'll start it off and then I'll let you finish the last part after 6 years. So how do we find the value of something that's losing 3% a year? So notice after 1 year, losing 3% means keeping 97%. So after 1 year, you now have 97% of 180,000, right? This is, let's make a little table here. After 1 year, you have 97%, which is 0.97 times 180,000, right? After another year, right, now you only have 97% of what you had here, which is 97% of 180,000. Okay? After 3 years, now you have 97% of what you had the year before, which is this right here, which is 0.97 times 0.97 times 180,000. So what do you notice about the 0.97 and the number of years? It's to that power, right? It's 0.97 to the third, or after 2 years it's 0.97 to the second, or after 1 year it's 0.97 to the first. So the value, I'm going to say V of t for the number of years, is 180,000 times 0.97 to the t power. Notice after 0 years, that means initially, right? It's 0.97 to 0 is 1, so the value of 0, time equals 0 is 180,000. The value for time equals 1 is this one, right? Not 0.97 times 180,000, whatever that is, right? All right, so that applies to any time t, and so I'm going to let you guys in class find V of 6. Okay, so you get to do that part. All right, let's start off number D. Oh, I think we're going to cut off here. So I'm going to say we pick up after that on the next